Hello, I'm
Hey,
Maria,
I'm Gurpreet.
I'm Jay.
and this is our presentation on caching strategies and Distributed systems.
A comparative analysis of LRU, LFU, and ARC.
So this is kind of what we're going to be touching on in our presentation. Just a little table of contents, just to know what to expect. So first, we're going to start off with our introduction, just to get you familiar. So what exactly is caching, and what is a distributed system? So a cache is just essentially a piece of hardware or software that just temporarily stores data, and it's used in order to decrease latency and speed up data retrieval. A distributed system is just a network of computers that work together and they operate as a single system, and they all work towards a common goal. So the computers in a distributed system are independent, but to the user sees them as one single working machine. They don't know that it's multiple systems behind the scenes. And distributed systems offer redundancy, better performance, and better availability, and improved resource sharing. So these are different available caching types, and we're only going to be touching on distributed caching in this presentation, but they're all pretty much the same but used in different scenarios and in different ways. So, how does it all work? So, first, when a user makes a request to something, the user's requesting for some kind of data, it'll make a check in the cache to see if it's already in the cache. The data that they're requesting for already exists. And if the data is in the cache, then it can be quickly returned to the user. So it saves time and reduces load on the primary storage, like the database. But if the data is not within the cache, which is known as a cache miss, the system fetches it from the main storage, which can take longer. So after the fetching happens, the system stores this data in the cache for future requests. And this improves efficiency for all future requests afterwards. So here are some keywords or some definitions that you should know for our presentation and for our future works. Is the cache, which you already covered, which is just a storage layer that keeps a copy of frequently accessed data just to speed up the data retrieval process. A cache hit, which is when the requested data is actually found in the cache, so leading to quicker data retrieval. A cache miss is when the data the user is requesting is not found in the cache. So it requires the system to go and fetch it from the main storage, which is usually a database, which can be slower. The eviction policy, and this is highlighted because this is the importance. This is what really changes or distinguishes our different caching algorithms that we'll be comparing. And an eviction policy is just a rule that determines which data to remove from the cache when the cache becomes full to make room for the new data. So it's how they go about figuring out how they're going to do that, the policy they follow. A distributed system, which is, like we said, a collection of independent computers that all work together as a single system, all working towards the same goal. Latency, which is the time it takes for the data to travel from one point to another in a network. Scalability, which is the ability of a system to handle a growing amount of work by adding resources to the system. And fault tolerance. This is just the capability a system has to continue operating even when one or more of the machines fail. So now we move on to the overview. So, caching and distribute systems. Performance. In distribute systems, caching is essential to improve latency and improve data retrieval times, which are critical for large scale system performance. Scaling and efficiency, distribute systems are able to handle more requests with a reduction in processing time and resource consumption when they store frequently accessed data in the cache servers. Internet and cloud services. So many distribute systems are part of the internet infrastructure, like the cloud computing. Most of the time, people think of distributed systems, they think of the cloud. Even though they're not exactly interchangeable, that's just the most common place where it's really used. And this is where caching helps manage the massive amount of data traffic and improve service availability and reliability. And global reach. Caching techniques are used in many nodes across the globe and ensure that users can obtain data quickly wherever they are in the world and to shorten the distance that the data travels. Real world example. Okay, so now we'll move on to a real world example to give a better idea of caching and distributed systems. So let's imagine a worldwide e-commerce website that gets thousands of requests like every second all across the world. Like this is many websites, very common. So keeping all product information on one server that could lead to like many bottlenecks and a lot of crashing, a lot of failure. So when traffic grows, our information is retrieved from far off places. So what's the solution? Product information is kept on several cache servers spread over various areas, and this is where the distributed aspect comes into play because we're spreading it out over several different locations. So it's multiple, it's replicated, distribute. So the system obtains the product details from the closest cache server whenever a user visits the site. And this, can lead to faster response times, better scalability, and of course reliability. So here, let's finally get to the bread and butter, the caching algorithms themselves. So here we have least recently used, our LRU, least frequently used, LFU, and adaptive replacement cache, ARC, or ARC. So LRU removes the least recently accessed item first. This approach assumes that the data that hasn't been accessed recently will not be needed immediately. And the reason that there's a turtle right here is because this approach is the most simplest, you could say. So it's the most simple and the most steady. So a turtle. And LFU. LFU evicts the items that are least frequently accessed. So this policy assumes that items accessed less frequently are less likely to be needed in the future. And the reason for the elephant is because it has good memory. It remembers the ones that are not used as much as in its eyes. And then adaptive replacement cache, or ARC, or ARC. ARC is dynamic. It balances between the two we just mentioned, and based on different patterns, it watches patterns of data usage and is able to adapt accordingly. And it's reason for a fox because foxes are adaptive.
So this is one of the algorithms. This is the least recently used algorithm, also known as LRU. So as discussed before by Maria, LRU removes the least recently accessed items first. So the advantages are that it's easy to understand, it has efficient use of caches, and it's fast in terms of performance. And one of the disadvantages of the LRU algorithm is it needs larger cache to increase efficiency. This can be costly to operate, and it requires more data to operate. And in terms of error detection, it is difficult compared to other algorithms. So for the LRU example, I have a list of commands on the left. And for this scenario, the cache size is 3. And if you use the put command, it inserts the key and value into the cache. The get command returns the value of the key and updates the recently accessed item. If the get command returns null, it returns a -1. And if the cache is full and put is commanded according to the algorithm, the least recently used item will be discarded. So I have 4 boxes here. So put A1 will put the first item into the box. Put B2 will put the second item into the box, which is on top, which is the most recently used. Put C3 will put the item into the box. So it's kind of like a stack. And then if you do get B, it will output 2, which will move that item to the top because that was recently accessed. And then we also got another continuation of the command. So get A will output 1, put D4 will remove D3 since that was the least recently one. So push that D4. And then get C will output -1 since it's not in the cache. Get D will output 4. And then to the second algorithm, it is least frequently used algorithm, LFU. So for the advantages is that it checks the frequency of each item before removal, and LFU can suggest frequently used words such as words when typing. So the main disadvantage is that old items that were inserted into the cache and has a high frequency count may have a hard time getting out of the cache when not frequently visited, which we'll see in the example. So for the example, this is like the cache request. So the cache size is 4. I have the yellow table as the frequency table and the blue one as the cache. So when you do the request, it just inserts the um item into the cache. So if it's C0, it'll update it to 1, C1 it'll make it 1, and then C2 will make it 1. And then for this is the same as C3. When you put it in the cache, it will make it full, and then all the frequency are 1. And since if you do cache request 4, this is when it will check the frequency to remove something. Since they're all the same, it'll use first in, first out, which will remove C0. And then request 2 will just change the frequency to 2. And then this will just continue onto the same pattern as discussed before, which will just update the frequency as requested below. And then see this last part will just this is the updated tree request. So at the end you can see that when you do the 5th request and the 6th request, it removes C5 and then puts C6. So this is how the LFU algorithm works. And then with this example, you can see the disadvantage, which is that high frequency items that were older, when they tend to have a high count, you can't remove them. So let's just say that the cache request extended to 5.6, 5.7, 5.9, 5.8, we will be able to see that 5 is the high frequently item, but since the count will never exceed 2, it can't override the cache.
So some of the issues that we thought of was some of the vulnerabilities to large data loads, and with LFU can struggle with handling with large volume of data. And another issue we ran into is handling changing patterns for LFU. It doesn't adapt well to changes in access patterns. And then also another one is memory usage. Like a simple caching method like LRU can be lightweight, but more complex algorithms can use more memory due to its additional data structures and its complexity. While LRU and LFU are simple, ARC is more complex because it balances between LRU and LFU features. And I'm going to talk about some of the objectives. So our project scope is analyzing some of the different caching algorithms. We're also going to be implementing them and running simulations. And we're going to be dealing with concurrencies. And we're going to use evaluation metrics to measure the performance. And our objective is to compare the scalability, performance, and the flexibility of the different algorithms such as LRU, LFU, and ARC. And our methodology. So our plan is to analyze some research papers, which is our literature review, and then we're going to implement the different algorithms by simulating it in Docker containers. And we're also going to be doing some load balancing, and we're also going to simulate some traffic. And then at the end, we're going to have to log the data and use metrics to gauge its performance and our current status and research. So here's some of the tasks we have listed. And right now we're on the web server setup. And our in progress is our algorithm implementation, which is going on right now, and the rest we haven't started yet. And that's about it for our current status. And here's some of our references. So the references are our research papers we did our analysis on, and there's more on the other slide. And that's it. Thank you.
Thank you, guys. Do you have any questions?